Okay, so what is the traditional way of installing? How do we normally been installing? Earlier to, or say beginning of maybe the 2000, early 2000 and thing. So the normal way of installing a server has always been that we would use a CD-ROM, then change your boot sequence, and then run through this whole process, right? That's the normal way. That's the normal way we used to do at those times, and it continued for quite some time like that, because we did not have these number of servers what we are talking of today. The servers were hardly in the tens range basically than the thousands we are talking of today. So that was the standard way that we would provision an OS. Okay. Now, so during I think during that time, I think it's early 2000 if I'm not wrong. I think or I don't know when. Yeah, this concept called network booting came into picture. Okay, so what did this intend to do? The intent of this was, now instead of using CD-ROM as a way to install, can we do this installation using using a server located elsewhere? And instead of using a CD-ROM, can I use a common server and pull down your operating system files, boot it, and then do the complete installation? Was that possible? Now that was the attempt which was done using what is called as this network operating system, and we'll see of that. Okay, so here in this slide, he's generally talking about what provisioning is all about, and there are so this is about an application provisioning stuff as such. We will come to this. Okay, now so this is what I was trying to talk about, how the whole installation of operating system would happen over the network. Now, how did this all happen? Okay, so let's try to understand this whole picture about how we could do this installation of operating system. Now, having so I used to work pretty extensively with these Unix servers. When I say Unix servers, specifically with the SunSpark and IBM's power servers, they all had this great utility of installing it over the network. So coming from a background of Sun Microsystems, we had this server called Jumpstart server. So what would the Jumpstart server do is, it will help you to quickly provision all your systems over the network in minutes compared to the traditional time of installing it through your CD-ROM. And they used a couple of softwares to enable this. Now, the same utility was then, not the same utility, but a similar approach was then adopted for your x86 environment. Though in x86 environment, during those times, we didn't have that much of a network-based installer, but later on, when this NICs, basically the network cards, came with a particular chip embedded into your network card, which would search for these so-called booting servers when you actually start. I mean, you should have noticed this sometimes, that a client's, your DHCP client looking for any, and I'll show you that. I'll show you that whole implementation in the lab as well, and we can do that today. Very surprisingly, on my on a virtualized platform itself. It's become so advanced as of today. Okay, so today, as I said, the first two softwares what you would do installing when you in a fresh data center is, first you would do a DNS, a DNS and a DHCP, and then you followed with one of these tools, either a Kickstart or rather a cobbler, and there are other tools like Foreman, and I think there's one more which Dell uses, Crowbar. So we use one of those tools along with the rest of it, the Kickstart and various other tools that we will see as we go along. Okay, so this booting. So one of the key requirements of provisioning is the hardware server's ability to boot over the network instead of the DVD. A pre-boot execution environment is one of the methods that allows to boot over a network and install operating using the remote environment. So these installs were actually called as PXE boot environment and things like that. Basically, it's a combination of protocols which enabled this booting of your operating system, booting of your server over the network. Okay, so it depended upon, as they say, 3 protocols. Today, actually, we do not require NFS. We can just do it with your DHCP and DFTP. The earlier NFS was the way to do. Today, as I said, NFS has slowly been replaced, and we predominantly try to use HTTP as the protocol for the way to go. Okay, so what did these systems come with? All these systems came with a specific network chip which was embedded in your network card, and what this would do is when this starts up, when your operating system, when your server starts up, the first thing it will try to do is get an IP address, and that is why you require a DHCP. Okay, it will try to get an IP address. Once it gets an IP address, now once you get an IP address, that means he is connected to the rest of the world, right? That's the whole idea, be it internal or maybe external. Okay, so it gets the whole, it gets the connectivity that is required to talk to anybody. It's just like for him getting a telephone number. Okay, once he gets an IP, then he starts searching for the boot server. Okay, he starts searching for the boot server, and boot server is nothing but what is called as a TFTP server, or it is a lightweight FTP server in which there is one code, one executable called the. So if you want an operating system to boot today, you require a kernel, right? This guy has a network-based booting kernel. So your machine, your server would locate this server and pull down that small small kernel, which is nothing but sometimes they call pre-boot kernel. He pulls it down from the internet. From your network, that is from your booting server, which is nothing but a TFTP server. He pulls it down, boots it. Okay, once he boots that small environment, he is now in a position to for him to locate the next step, that is the actual operating system itself. So this guy in turns pulls down the actual kernel from another server. This time, instead of NFS, as I said, it's a HTTP server. your entire actually CD-ROM may be residing in this particular, mounted on this particular. He actually pulls it down from there, and then he tries to install it. Okay, so so this is how this whole automation of your server booting happens. Actually, it's a complete installation. Okay, so now how does this whole thing work? Now there are a couple of things before you start before you make this work you have to do. As I said, first thing is installation of your PXE server. Okay, what is a PXE server? It's a combination of DHCP and TFTP. Okay, so today, as I said, we don't use FTP or NFS. We prefer to use HTTPD. Okay, so DHCP, TFTP, and HTTP combines to form your PXE server. Now, what does the DHCP give you? It gives you the IP address. So this guy wants to install the operating system. So what does he do? He will, because this system has a network card, and that network card, as I said, a PXE bootable, PXE enabled network card. He will go in search for your, I said a pre-boot, a small software code code called pre-boot environment. He first downloads it. Then once he gets a DHCP, then he gets the pre-boot environment. And once he gets that, he will then go in search of your where your actual kernel is, which is residing in your HTTP server. Okay, and remember, all of this actually should work in your what we call as a single domain. So which is very important. Now, the other thing you should remember is, see, when do you use your PXE boot environment? Because in today's cloud scenario, a PXE boot environment is one of the most important part, but it is not used extensively, and I'll tell you why in a little while from now. Okay, so the PXE boot environment today is utilized to do only two things: install operating system on bare metal, or install hypervisor. I hope you understand this word hypervisor in your bare metal. So this is basically a bare metal. It's basically a bare metal installation scenario. Okay, so we should understand this because in the cloud environment or other environments, we don't use this to install your operating system. The whole intent here is install your operating system for bare metal. When I say operating system, it is two types: either a full-fledged operating system or an hypervisor. And hypervisor could be either a VMware or a Zen server. Whereas when we talk about virtualized, we'll see a little more of the other thing as well. Whereas if it's CentOS, if it's Red Hat, your KVM and if it's Windows Hyper-V, they all come embedded in itself. So this is your first environment. So imagine you want to now install 100 systems, right, in one go in your data center. We could have we could install a couple of PXE boots, and we can have all of these systems talking to the PXE boot to do the installation. Okay, now another question arises: is the PXE server alone okay to do this entire installation? No. Now this is where we have this file called Kickstart. Okay, so so I use the word jumpstart server, right? In Spark it is called jumpstart server. In Linux it's called Kickstart. So what is this Kickstart server or Kickstart file? So this is a file which contains a certain information which are common to all the servers. In the sense, when the server installs, it needs it needs maybe a fixed IP. It requires certain applications to be installed, right? It may sometimes require a username and a password to be configured. There are various things that needs to be configured and installed for each system, and these configurations may vary from system to system, right? So all these configurations are kept in this particular file called Kickstart. But if you imagine the situation where there are like thousands of servers, right? Thousands of servers, as on the big five, be it Yahoo, Google, or LinkedIn. Then how do you manage so much of these configuration files? Now that is where these tools like, which I think I just mentioned previously, Cobbler, tools like Cobbler, Foreman, and Koban are coming in a way to help you actually manage these configuration files, as well as probably the respective images itself, right? We are talking here of basically CentOS. Maybe this environment can have multiple other OS, SUSE, your Ubuntu, anything. So these servers like your Cobbler servers, Foreman servers, or Crowbar servers, they help you to manage these images and manage these profiles. And what are these profiles? Profiles are the individual attributes for that respective machine, which should get installed when you install your operating system. Okay. So are you getting this by now? Any doubts that you have on this particular part? What PXE environment? This is the first level of automation that you see in a data center. Even before you install your application, you've just started implementing your data center. As I said, and as I keep repeating that, after DNS, DHCP, you actually build your PXE boot environment. And what is PXE boot environment for? To install, your software, that is basically operating system and or your hypervisor in bare metal scenarios. Okay. So I think I did tell a lot about this. So how does this whole thing happen? There is a target machine. Sometimes it just helps a little to show you with the lab. I'll just show you a little bit. So if I take any of these machines, I'll just take one of these machines. And if you see here, earlier, we had the option to, the Windows DOS and Windows, those Windows 3.1 all were through floppy, right? So we also have this option called network booting. So if you set network booting in your laptop or servers or whatever, it will start booting through the network. Okay, so this is where the option. For this to function, we have to set up the PXE server. Okay, so that, of course, this whole exercise we are going to see as a part of the labs. And so I hope you kind of understand how this is all working. And I said, so the next step is all the for your PXE boot to work, you should have your network card with those embedded chips. Earlier, these network cards did not have this PXE chip. Now by default it comes with these chips. There's no network card which does not actually come with this thing. Okay, so again, continuation of the same process of how this actually happens. And I said first, I think, yeah. So the first step is to identify where your first step is to get an IP address for your machine. Once you get an IP address, we look for where that PXE server is, and it downloads a small boot image. Once the boot image is downloaded, it then searches for your actual booting files. That's your actual kernel. Okay, and once that is all up, your system is able to install. So when you install, what is happening is it's actually referring to this file called Kickstart file. It is in this file where all your configuration information is kept, and based on that, see, look at the normal installation process. What and all things we are giving? We give a host name, we set your time zone, we set a username, password, we set your server partition, hard disk partitions, right? And you may also say that I want to additionally install all these items. Now, all these steps, literally every step that you go through when you're installing through your CD can also can then be automated using this Kickstart. So once you just switch on and you have this configuration file, it downloads everything, installs everything, and you're ready to it installs everything, and that's it. It installs, and in the next step you realize that the machine is already installed and is ready to boot. Okay, so your whole installation will be done in seconds, not really seconds, or maybe few minutes compared to the traditional. But here it is. What do you need to do such an installation? You just need to plug in your system, power on, and make sure your network card is your network port is connected, and that's it. The entire installation is done. By the time you're back to see the other systems as such. It's basically sometimes also called as unattended installation. Okay, so you can do this with any kind of operating system, be it your Linux world, your Windows world, or your traditional Unix world as such. Now we also added one more layer, that is installing the hypervisor in the same way. Okay, so when I say hypervisor, it's basically the virtualization operating system. Okay, so this is basically the flow. I think we would probably be seeing a working a lab of this whole PXE environment. How do you configure these? And we will actually install an OS based on that. Okay, so Kickstart is the process of automatically answering the questions at various prompts during installation. This method is primarily used by Red Hat to perform unattended installs. Okay, and Kickstart configuration files can be built by three ways: by hand, GUI, or other methods. So we will be actually creating a Kickstart file to do this complete installation, and then we'll see how to create a Kickstart file and then integrate this to your PXE boot environment to do that Linux installation as such. Okay, so it's the same thing about how this whole process works. In the left side, we are talking of how it would work in a manual. So earlier, Kickstart could also be installed through a CD-ROM as well. What happens in this kind of method is you so how does this differ from the general CD-ROM? In a general CD-ROM method of installation, you need to keep giving answers to all those prompts which occur during the install etc. Instead of that, we can just give a Kickstart file, give a CD-ROM, and then it pulls up the Kickstart file and it does an automatic installation. Okay, but of course you require a CD-ROM. So if you see as of starting probably I mean last year or I think as of this year, CD-ROMs or CD read writes are literally disappearing out of the market. You are not going to have CD-ROMs anymore. Everything is now going to be through a USB in case if you want to use USB. If you see the trend, otherwise in the desktop market, Macs have completely removed out CD-ROM from its collection of the netbooks, right? So, I mean, that's going to happen. I think in the next 2-3 years, CD-ROMs, the CD rewrites would completely be disappearing. Okay. And this is the other way of installing, which I've talked extensively about using the PXE boot method. Okay, so after you kind of you boot your system, right? It comes to this welcome screen automatically, and it picks up. So if you see down here, okay. So you know the Linux kernel is made of 2 files, VM linus and initrd. Okay, and what it says is it picks up KS is nothing but a Kickstart file. It picks up the Kickstart file from this particular server and it does this complete installation. So this is what you're actually seeing here. Okay. Okay. So I'll be showing you a detailed demo of this. Yeah, it will take a couple of some time. After we finish the this particular theory, we will do it. It's a pretty long demo though, because there are so many things like as we saw in the DNS setup, we have to configure to put this in place. Okay, so apart from your automatic installs today, we also have to ensure automatic updates, right? But though there are automatic updates, now this is the first form of automation that kicked in the early 2000s, right? Everybody wanted a tool where we could by push all your these I mean specifically in the Microsoft environment on the desktop side, we wanted to push in all these antivirus files. We wanted to then you know update all your systems to the latest package levels and stuff. So this was the first automatic system updates for the first attempt to do this. Earlier, you get your updates in your CD, and then you put the CD, and then you used to update your operating system and all that. So the first attempt to start this automation was with your packages. And now you know that everything is okay. You connect to your net and then pull down all your files if you have your licenses. It is as simple as that. But earlier we had this Microsoft management server and things like that to kickstart this whole process. Okay, so applications in Linux systems are organized in the form of packages that contain your binaries, configuration files, and Linux uses Linux or basically Red Hat. Each one has their own packaging system, right? To facilitate the installation, upgrade, and removal of your packages. Now all this, so yesterday we saw, right? We used yum, and that's how we installed all of this. The next question arises: how do you create those packages for you? And I think we will be doing one small package for our application, so that can be distributed like your yum repository. Okay, RPM is a command line tool and keeps track of package version and files contained in it. So what is this RPM and why do you want RPM? Okay, now we have some questions and let's speak to JR. Hi, JR.
Hi. So I was wondering, do you use the same Kickstart method to even kickstart a VM,
Okay,
or
so
is there any
yeah,
other effective method that you could use?
okay. So let me explain that. So as a part of today, we have various forms of operating systems. So may I want to call as, though it is not the case. One is installing everything on the bare metal. Once we install something on the bare metal, we may choose to install operating systems on top of that, right? If there is a virtualization layer there. So in that case, what happens is basically installing your VMs is normally done through cloning rather than a Kickstart server.
Oh, okay. So you can do the cloning of Linux cloning even with that.
Yes. So I mean, I'll just show you. Sorry, it's as simple as this.
Okay.
Let me. If
No,
I take this.
Yeah, if you're covering on the further chapters up in the further weeks, I don't want to see it now.
Yeah, I mean, in the sense when I say show you, I mean just to show you what that means all about.
Okay, fine.
But of course we will talk extensively. I just pick one server here. Okay, I right click and then I say clone. It is as simple as that. So you just clone it. So what happens is, so that's why I was emphasizing as I was doing this, all bare metal installs will go through your Kickstarter.
Okay.
That is, if you want to, today we don't use, I mean, unless it's your desktop, if it's your server side, all server side is going through a hypervisor way, right?
Okay.
When I say hypervisor, we install either a VMware or a Microsoft Hyper-V or a Zen server or any of these things. So the first install, which is the bare metal, will go through Kickstart. But beyond, once the OS is in place or the hypervisor in place, we never use Kickstart again.
Okay.
We go through some kind of a cloning process.
Okay.
Or any other method. Basically, it's the cloning process. And I think sometime back somebody has asked this question: do we install your operating system through a configuration management system? So I told you sometime back, configuration management system is only to update your configuration files, right? Like yesterday we saw. But we could use provisioning, like a Puppet and tools to actually install your VMs. So how does that happen? That all happens once your hypervisor. Okay, so you're getting this up, getting this stuff?
Yeah, I have another follow-up question. So when you're cloning, so what happens to the IP? So you have to change the IP, right? The range would be there for a ESXi.
Yeah, see, now, good question. Now you're getting the, see, this is where, once your thought starts coming in and you start putting this whole solution in place. Very rightly said, when you clone, everything gets duplicated, right?
Yes.
Everything gets duplicated.
So that is where, everything gets duplicated. So for a bare metal, if I have a simple Linux install, all that, then I could clone it. But still, I have to change the IP, and I'm sure it will be a range that would be provided when I am having an ESXi clusters. So for example, I will have a class C, some kind of a range, IP will be reserved. So I should be using one of those IP addresses. Am I right?
Right. So let me explain that whole situation to you. Once you clone, your IP gets cloned, your MAC gets cloned, right? Your host name is so everything gets cloned. Everything gets copied. I mean, it's literal duplication. So the first thing that we do is in these environments, we do not clone from an existing system. we create what is called as a template before cloning. So when I say template, what do we mean is we now by any stretch of imagination, we need to do at least one installation of your virtual machine through a Kickstart server. Okay, so having said all of this, I still need to do at least one VM through this process. There is no other way out for me. Else, if I can't do that, then I will have to go through this process of P2V and stuff like that, which is a even tedious process of this.
Yes, exactly.
So if I don't do that, I have to do at least one VM through this Kickstart installation, and that's about it. After that, we only clone. So I create this VM, and I do what is called as a sysprep it's actually a Windows term, which is today applied in Unix. And when I say Unix, I mean Linux as well. Sysprep is a set of is a tool which will literally clean up your entire VM. That means if I go through that process, he will remove my MAC address, my IP address, my machine names, my log files, my SSH files, and anything that may be part of the duplication activity. Okay, so we go through this process. Once this is done, this VM is an absolutely clean image without any data which can be duplicated. It is a absolutely clean image, and then we clone that. Okay.
So basically, a boilerplate or a templates that you are creating.
Yes.
Okay.
And then what happens is once you clone this, once you clone an existing VM, and when that starts up, it automatically generates a MAC address, it gets its IP address, and it may or may not have a machine name. Now, how do you then apply the other changes, right? You want to apply a machine name, or you want to install something, because it's a clean slate, right? Now, This is where we use your Puppet servers to do the rest of the implementation. So, are you getting this picture in now?
Yes, now I'm getting it. So if you're further covering it on the other classes, I can wait. No, not an issue. But now I got the glimpse how it is.
Why I was talking so extensively is because these are those simple questions which sometimes confuse. And once you can put all this in place, right, you get the full big picture. So I hope to the rest of the class as well. So this is how the whole process happens.
Okay, thank you.
Sure. Okay, so I hope I think these questions are very nice, and it helped us to put in a flow of this whole solutioning, right? And it's most about picturizing the solution. That's where we all get into a problem. And so now very clearly we are able to visualize where your PXE environments are, okay, where your probleming tools would come in, okay, and this whole concept of cloning, cloning varies from place to place. What we saw because I have a hypervisor on my laptop, that's why we were able to clone. But otherwise, there are other methods to clone and do things out. Okay. So RPMs, Red Hat Package Manager, and why do we require this? Now the thought is we also need to automate our installation of our packages. Now when I say packages here, it doesn't mean packages which are only coming in that CD-ROM which are released by Red Hat. We may also have to create our own package. So how does this help? Once you create your own package, you can then use the same repository to install this. Now your package may be as simple as a shell script or a Python script, and you're going to use this to actually, you'll take this file and then you convert it into an RPM, and once you convert it into an RPM, you can use yum to install. And this is where this whole process of application automation comes in. Okay, we talk so much of CI/CD, right? So your Jenkins servers, once somebody checks into the code, he then pulls then this code is pulled out, and using RPM, or so RPM is just one of the way of packaging. Okay, there are hundreds of ways to actually, each one creates their own packaging tool and format and things like that. Okay, so this guy, the Jenkins, he checks this out, he takes this code, okay, and he creates a package of it. Basically, we are what we are doing is we are kind of doing a tar of this file, and we are putting a lot of other management information, and then we'll see a process of how we'll take a file, just one line file, and how to create an RPM, and how that can be distributed as a part of your activity. Okay, as a part of this CI/CD as such. Okay, so we had RPMs, then why is this yum coming in, right? This is a little confusion. Okay, so RPM is a tool to develop your packages. Okay, yum is a repository, right? It's a repository to store those packages in a form of a group, so that all the so all dependent packages can also be installed along with that. Okay, so I hope you're getting the difference between RPM and yum. So yum, RPM. So I want to clarify here, RPM can be used to build a package, and it can also be used to install that individual package. Okay, it can also be used to install that individual package. Whereas yum is basically a repository. And yum is not the, again I want to tell you, yum is not the only form of repository. There are various other forms of repository, and each one can create their own form of repository. Okay, so like I mean, I know coming from one of these big guys, each one had their own. They won't even bother to use RPM. They had their own form of packaging, and they had their own form of repository. They'll create their own repository and use it to install. So, but as I said, all enterprises would prefer some kind of a standardization, and they use yum in a big way to do the installation if they're using on the Red Hat, because Red Hat being the largest. But if it is Ubuntu or SUSE, then there are other forms of packaging and then installation. Okay, so yum automatically resolves dependencies and determines which package needs to be installed in addition to performing a successful package installation. RPM does not do this. It basically packages and installs that individual package alone. Yum also supports the concept of package groups, in which a list of related packages can be assembled into a group and installed by using the group name instead of individual name. So I hope you could have, if I take one of these systems, okay. So if I would do this, Okay, so can you see this stuff? You could package your applications into groups. So if you wanted a complete Java platform, and then you can just say yum group install as a Java platform, or you could have a development platform. So there are various ways you could group it, but these are default groups. Okay, these are groups which exist as part of your existing yum tools. Okay? But you could group it that way. So yum also supports, okay, yeah, I've done that. So yum is capable of downloading and installing packages via various transport protocols like HTTP, FTP, or from your local. And today everything is around HTTP. So no more FTPs and no more NFS shares, NFS way of installing. Everything is got consolidated into the web way of doing things. Okay, it makes easier to maintain groups of machines without having to manually update each one using RPM directly. Okay, so I hope you understand what is yum and what is RPM as of now. So yum repository is a central location for all packages, and by using just a yum command, packages can be installed across thousands of nodes. Okay. Now, the first thing is how to know what your central locations are, right? That is the first thing you need to know. So this is the place. I think yesterday I went here, right? This is the place of these location for. This is the place where you find the configuration file for that particular repository. Now, yesterday when I tried to install Nginx, I couldn't install. So by default, when you install your CentOS, only these repositories come in. Okay, so what are these repositories? Each one of them shows you a repository of some respective application. Now, Nginx does not fall into the standard CentOS repository because this is an application developed by some company, right? Some company or some organization, and he's not keeping it in the central server of his various CentOS operating system is. Right? So he keeps in a separate place. So that is why we had to point to that particular server, and that was located at here. So if I do, okay, so in this he will point out, as you see this here, he will point EPL is a central repository, okay, which is mirrors.fedora.whatever that places. Here the Nginx is located. Okay, so this path etcm repos.d is a place where you find all your pointers to the central server. So if some application you are not able to install, that means you need to add that particular repository. Example, let's say, yeah, I mean, you want to install, Hadoop. So this may be not located here. So I will have to then go and point. I'll have to then go to that particular repository. So I know it is in there. So where do you go? I would need to go to, say, one of those three standard guys, your what do you say, your Hortonworks or Map or one of them, and they will have your he will have that file, which is nothing but .repo file, telling where your central location is. Okay, so we have a process of going through this. Now, earlier we had all of these configurations in an FTP and VSFTP and all these things. Now all this is dead. We only have these repos through HTTP. That is one thing. We can also create our own repo server and then distribute it as well. Okay, so we will also see that small process of how to create our repo and this is what happens in an organization. Okay, see, we don't allow any server to connect directly to the internet, right? We don't allow any server to connect to the internet directly. That should not happen. So what do? You create your own repo server within your organization, and it can contain packages from various sources. See, when you create your own repo may be serving Hadoop as well as it may be serving Hadoop as well as it may be serving Nginx. Okay, so it could be one repository with all of these files. So what does the repos contain? It contains your RPM files. And how do you create your RPM? You use an RPM tool to create. Okay, I hope you are kind of understanding this now. Okay, so we run through a lot of these. When I say Yum and RPM demo, the demo is nothing but running the commands, and we'll go through a lot of these commands, Yum and RPM. Okay. Okay, so we can automatically we can set automatic updates for Yum and things like that. Now, yeah, we are not going to do this often, and though the concept and the configuration and the packages are there, we are not going to do this primarily because we never update a production server as it is, right? So we do go through we could do a automatic update for your desktop, but that's not the case with a server. We will have to go through a completely different process of updating any server, right? Okay, so so this as I said, RPM is one way of actually creating a package. There are various ways to create a package. Why do you need to create a package? Without creating a package, I can't use Yum as a tool to install, and that is why you need to create package. So, and how do you and what do you do as a part of the package creation? We take a set of files. It could be, as I said, as simple as a bash script or a Perl script or a Python script, and then we create a .rpm out of it. That is the end goal. Okay, as simple as that. And then copy this into your one of your repositories. So where is this repository going to be? That repository is going to be what you are going to create. Okay. So with root privilege, RPM command will allow you to create a package. So the basic procedure to build is get the source code, make a patch, any changes, create a spec file, and then build it. So it's just two things: get a source, create a spec file, and then run it. And we'll do this. We'll do this as a part of your labs. Okay, so the spec file is a description of a software along with instructions on how to build it, and a file list for all the binaries that get installed. Okay, and it is normally a .spec, a file name with a .spec. This ensures that the spec file remains intact during installation of your multiple RPM, source RPM, for various versions of the package. So, okay. So one thing is, as a part of your, as a part of this DevOps activity, packaging is one important part. But normally you will have a separate team who is handling packaging in enterprise level, and this is some activity. Personally saying, even I'm not so thrilled about. It's a little yeah, it becomes a little mundane as it goes along. It's just good to see as a part of your lab and things. But you have huge set of teams sitting and creating these packages. But whereas now I'll tell you how I used to use this. So when I used to write my own scripts, right? When I say scripts, these are Python or Perl scripts, which will do some activity. Could be some monitoring or some, or it could be a small socket program, whatever. Now, once I create these scripts and I have to copy this across my 8,000 odd servers and things like that, right? I can't just copy as it is. It has to go through a process. It has to. So how do you go through this process? I take this I take these files, convert first into an RPM package. Then you'll have to go through the normal cab, the ITL process and stuff like that, and then push this into my provisioning server, and then you start applying, right? So you go through this whole process. So in that process, one part was to create my package, because I'm creating that software myself. So in those cases you would do, but ideally, yeah, you would not be doing this. It is just good to know that you also know how to do what is this packaging as such. Okay, so this is a standard spec file. I said, right? So how do you package? So to do package, it's very simple. You copy all your files in a particular folder. Okay, there are actually 3-4 folders that you create: source, build, and spec, and things like that, and RPM. So in the spec directory, you'll have the spec file. Okay, it tells you the summary of that whole package. What does package, its name, its version, etc., where the build route is, then what do you need to do as a part of it. Okay, and when you install, what are the directories that you may want to create. Okay, and those entire information about if it is a C file, you'll have to compile that. So all that information is kept in this spec file. Okay, and I'll show you a simple one of this. So this is a general spec file. Okay, it contains a lot of these information. Okay, so you want to create a group, and this is it. Okay, so this is a group that the package belongs to in a higher level package tool, and this is how you create a group of files as well. And this is how you create your dependencies. It's in this place where you start creating your dependencies itself as a part of that installation. Okay. Okay, so group is used to tell high-level application program where to place this particular program in its hierarchy, and you can see that. And the build root allows you to specify a directory as the root for building and installing these new packages. You can use this to help your thing, and description tells you what are they. So there's a whole set of information that you find in your spec file. And as I said, when we do one simple thing, you will kind of roughly understand this particular file as such. Okay, this is a continuation of that file. There are a lot of options. Okay, even I won't know much of these. I would only do it. I know a few of it which I have used, but there are a lot of things that can get into. I mean, you have actually a complete position for such kind of activity. These are called the build managers, the build engineers. They go through this complete stuff of creating these packages. So there's a complete team, and they would know to such deep level. But as I say, if you are building your own applications in this web environment, we won't have to use so many of these utilities. It's only very limited that we are going to actually use. Okay, and you can apply your patches. Okay, so this the whole process of version controlling and package management. I think there are a lot of that within your within that particular spec file. And there's also this build commands here to use, and once you use the build command, you're going to build it. But anyway, we will see this as a part of that particular whole process. Okay, you also have, if you do not get installed properly, right, cleanup. So there is a cleanup process if things don't get installed. This is where you specify all those options actually. What do you do? When you say cleanup, it's just basically deleting a file, nothing more than that. Okay, but you can specify all that in that particular spec file. So this is what we call as reverting, right? Sometimes the installation fails. How do you revert? It's because of these options which are existing in that spec file inside part of your RPM. Okay, you can also create a pre-install script, a post-install script, and uninstall script. Okay, so I think now we're kind of basically understanding what this, whatever that you do, no, as a part of a package. When I say you sometimes you install, you sometimes uninstall. Where is that whole process defined? It is here. So we might have quite often seen this in Windows, right? We do this uninstall, install, and where do you specify all that? But in Windows, we go the Windows way. But if it's in Unix, we go through this spec file, and that's why you understand it a little more easy compared to what happens in your Windows environment. Okay, so again, there is a lot of these. Yeah, I'm probably not sure why they have so much included, but you don't require so much of these options to do it. Okay, and you also have a change log. Okay, so that is one of the most important part as the process. And after all that, we are in a position to check if things are installed. So RPM, so as I said, RPM can be installed. Using RPM, we can install a single file, but it does not resolve dependencies, right? I will show you all those set of commands, if possible, today itself. Okay, so if you don't have YAM, this is the way to install that single package. I'll go through this process. Okay, I have a set of good amount of commands which gives you a decent way to go through this. So one of the commands is QA. Command is just to query all the packages which are installed. Okay, so if you want to know what is installed, you can go through RPM minus QA. That is one way to check it. Okay, and Q is used to query a particular package. So you want to just check if this package is there or not. Okay, so that's another way to do that. These are the commands basically. We will run through them. Don't worry on that. And if you want to know more information of that RPM package, we can do a QI, and it gives you all these things which you actually sourced it from your when you created a spec, right? I told you there's a spec file which you create. So that information is got when you use minus QI on a particular client. Then, now, if you want to see the list of packages which are part of your RPM, you can put an L, and it shows you all the packages that are installed in that. Included in the part of the package. Okay. Then, if you want to do an R, RP, it shows you all the dependency packages which are part of the that particular client. Okay. And then, as I told you, I'll go through this as a part of a lab in a very ordered way. For now, just understand that you have these options. So instead of IVH, you could also use an UVH. UVH is says that if the file is not there, install it. If the file is there, update it. Okay. And if you want to do an uninstall, you use RPM minus Z. Okay. Any questions? Okay, so that much on your RPM and your YUM, and then the other tool, your PXE.